Now, really honored to introduce Dr. Murali Balasubramanian from Stellantis. Firstly, thank you, sir, for your time to accept to give this keynote for the session one. I'll read a brief bio of Dr. Murali Balasubramanian, and then he'll take over for his talk. Dr. Murali Balasubramanian is a seasoned automotive R&D expert, more than 3 decades of experience in this field. He holds a mechanical degree from IIT Madras and a master's from Clemson University. He has been instrumental in bringing CAE, the computer aided engineering, to Chrysler in the mid 90s. He has contributed to virtual design, several of the Jeep programs. And after returning to India in 2004, he has helped scale a global engineering startup and later led virtual engineering at Stellantis. He is involved in fostering universities for different programs. He has spearheaded AI and ML initiatives, something which are really important right now. He's passionate about bridging the academia and industries. We had the pleasure of hearing him at the Indian User Conference just this year, and that's the reason we just want to hear more about his thoughts and how we can learn the skills that are required to be efficient and to be relevant in the upcoming years. He's also an Ayush certified yoga teacher. So if you have any interest in those areas, you can always connect with Dr. Murali Balasubramanian. Sir, the stage is all yours, and please go ahead.
Thank you, Zosimus. I hope I'm audible clearly.
Yeah. Yes, you're audible.
Yeah, I'm going to share my screen. So just give me a second.
Okay.
Thank you for inviting me. So I'm going to be talking about the bridging the skill gap. How do we prepare the engineers, or how do we enable the future engineers to meet the demands of the industry? So what I want to share is my experience both as engineering head, engineering representative in industry, as well as being a faculty for the last decade. So I can combine both perspectives and hopefully offer something, not just to raise questions, but offer a solution, a transformative solution, which might be something that may be relevant to all of you. So, so first I want to ask some key questions that I want to answer for myself, and hopefully it's relevant to all of you. So what's the 3 questions that I ask myself? One is the curriculum in the academia imparting all the necessary skills, critical skills? Second question is the industry academia ties fragmented, or is there more opportunity for a more integrated uh, integrated relationship between the industry and the academia? And are the students graduating ready to embrace the disruptive technologies that are relevant to today? So that's the main questions I want to answer. Couple of interesting facts is that 65% of the employers today report that the graduates lack the competencies required for today. And but also the academic institutions firmly believe that 78% of them believe that the curriculum is adequate. And interestingly, there is a poor correlation between student CGPA and the employability quotient. And another interesting fact is that the academia is involved in breakthrough solutions for industry problems. So how do you reconcile all these facts? Maybe all of them are true. There's something more we can do to bridge this gap. And I'm going to ask myself a question. Is there a role for bridge academies that bridge between academia and industry? And I think I see that Hexagon's efforts in this is pretty appreciable. So a little bit of example I want to use, virtual engineering examples. How do we walk from academia to industry competency? So in academia, we get as a student exposure to the basics, the fundamentals, which is essential for our preparation or our skill initiation and skill upskilling in the foundational aspects. But then in the industry, we are tasked with the engineers that get onboarded into the industry will need to be using these competencies to be addressing the use cases relevant to that particular industry. So here I'm talking about the automotive industry. And so the engineers need to ramp up in the standard tools, processes, use cases, the relevancy of um, the event, modeling of the materials in the systems, what type of analysis it is, etc. What kind of numerical method that we need to apply. But then that's not even enough. We need to be able to have these engineers be ready to take on tasks that relate to electrified vehicles, ADAS, um, SDV architectures, lightweight advanced materials. So there are a whole lot of challenges that they will be immediately thrown into, right? And not to forget that we need to have the state of the art simulation with multiphysics, awareness of digital twin library, uh, data engineering and applied ML. This is becoming increasingly important for engineers to be uh, uh, ready with, able to generate generative designs, use augmented reality, virtual reality, or mixed reality skills, bring it to the table for content generation, content creation, and we need to use statistics and data for the virtual simulation um, and the physical correlation. So how do we bring in the aspect of real world variability into our designs and able to model that using statistical models? So this is the level of competency that is required for the typical engineer, and it's important that we are able to impart that maybe elements of it upfront in when their education through the university framework. For example, a lot of our engineers at Stellantis work, simulation engineers work on what we call the meta model platform. So here we essentially use simulation models, simulation data emerging from parametric models, um, and then we uh, couple that with if available test data from the legacy database, and then be able to do simulations, build the machine learning models to augment our traditional simulation models or simulation environment. And this level of competency is expected of most engineers today. They are dialoguing with these kind of platforms to generate data, use the data that they generated from simulations and bring additional insights. Interesting challenges that we're facing is visualization, to go from traditional visualization um, to uh, to interesting visualization techniques like self-organizing maps, using optimizers, multi-response optimization, converting multidisciplinary optimization to multi-response optimization. So there's a lot of challenges that the engineers grapple with as part of a team that's handling a product development cycle. So the question that I want to pose is, so in the beginning, I spoke about the disparity. Academia thinks the curriculum is good. Industry thinks the graduates emerging are not ready. So what is the gap really? What is the need of the hour? So in my estimation, the need of the hour is a new pedagogical framework, new way of imparting these curriculum, new way of teaching. So it's based on Education 4.0, where we are talking about learner-centric uh, education, a innovation-driven education, where it is learner-empowered education, focused on industry competencies, also focus on interdisciplinary competencies, and of course, bring in the inclusivity and make learning a lifelong exercise, not prepare a student to be a lifelong learner. So these are the Education 4.0 foundation. And from this is what is emerging a new age classroom that I want to call it learnscaping. It's a hybrid pedagogical style. So let me give you an image of what I'm talking about. And this is emerging and this is becoming popular, but it is very, very nascent. So many people haven't heard about it. So imagine you're walking into a classroom and this classroom is teaching or the is addressing fluid mechanics and heat transfer as a course. But you don't see a classroom the traditional way. You see project teams in a cohort mode sitting in circular tables and working together. And there are here we are showing three cohorts. One is working on an Airbus A350 engine nacelle thermal management problem. Another one is working on the Stellantis lithium ion battery thermal runway management problem. A third one is working on a NVIDIA silicon chip cooling problem using impinging jets. So imagine that this is the classroom and these are all teams that are working independently on different projects. And you have your faculty who is now a learning architect, he's a mentor and helping these teams when they need it. Okay, so when they need it, so he's there, he's moderating some of these discussions, and a classroom becomes an interactive question answer, investigative, explorative classroom. And then you have a virtual remote collaboration industry mentor who's part of this classroom on a sporadic basis. So just imagine a classroom like this, and and the whole course predominantly is a sequence of projects. So each team is regrouped and they are doing projects. So this is the kind of new age classroom we are looking at. So it brings together three pedagogical styles. One is inquiry based learning, where students are actually given a problem and they're asked to research on the problem. So there's not going to be any spoon feeding. So with the emergence of AI and deep research agents, students are well able to research the problem, bring their learning to the table, help the faculty will mentor and help them define the problem, characterize the problem. They are able to address cross-domain involvement of the problem, generate questions to engage with the group and faculty. So this becomes your classroom and may or may not include industry mentors all the time, but sporadically. And then they actually generate a report of findings. So this will be a component of the learning. Then every learning exercise is contextualized with a problem. So industry academia collaborate to generate curated problems and bring the data along with it, the industry provided data. So these students are working on problems actually. So some universities are already doing this, but I think this should be the standard way of building your competency in students. So they are automatically, organically acquiring problem solving skills. They are learning to work in teams because of the cohort project execution framework. And most importantly, they are gaining experiential learning. So they are getting hands-on with physical systems. So industry not only provide the data virtually, but also maybe components, systems that are part of the testing environment, labs that they can donate or give loan to these universities. So virtual models, industry mentoring are also part of what industry brings to the table. So there is learning of project management. There is a learning of standard techniques for ideation, quality assurance, lab experiments, field visits, and all of this classroom is powered by AI because you have the deep research agents, you have the immersive content generation, you have automated project-based evaluation, etc. So an augmented reality visualization, and then you have remote collaboration. So this is the framework in which the classroom operates. And interestingly, what happens in such a environment is faculty no longer has become a content deliver, just delivering content, um, but they become learning architects. So they are actually becoming architects of a learning environment, right? And students are no longer passive receivers like a classroom or a lab, but they are actually empowered learners because they actually do the learning initiate the learning and only bring questions to the table which we can dialogue, right, as industry or faculty. So you get industry which are not just passive, rare participants, but become active learning mentors. Bridge academies. I believe there is a role for companies, business opportunity to bring this to the table between academia and industry. And why, for example, a company like Hexagon would be an ideal bridge academy because they are integrated with the industry as well as leverage the academia for their product development. So might be an example of how a bridge academy they are ideally situated to do this kind of activity. And then, of course, we need support from administrators, investors to bring in the necessary technology and infrastructure. One interesting thing that I did when I led the virtual engineering team more than a decade ago is I would take my teams periodically to the ride and drive, set up ride and drive events at the proving grounds, visit the crash testing or the four-port shaker testing. So get a touch and feel of the physical product and testing. So I think this is an important element that needs to be part of a curriculum and very regular. It's not just one-off visits, but regular visits to the proving grounds and the test labs. So what are the workplace proficiencies that are acquired by engineers? They are learning to acquire cross-functionally learning things. They are imparted systems thinking, project management, agile project management, digital collaboration with state-of-the-art tools as we do as a professionals. Uh, and interestingly, they are learning the process of problem solving, process of learning. So we want to equip the students with a skill where they can continuously learn for the rest of their lives. So the process of learning becomes important. So this is an ideal way of imparting a process of learning which is relevant to problem solving industry. Even research, I must say, because your research is an important element in problem solving. And then they are exposed to data driven decision making because data analytics is closely associated with uh, activities like virtual simulation, right? And then student performance is now more linked to project participation, contribution, and outcomes. So this becomes a more ideally environment for students to grow and learn and be evaluated on their competency. And what about the roadmap? What do I think should be how it should be implemented? This kind of a thing. I think there is a role for bridge academies to initiate this kind of a pilot, maybe a pilot, one single course on a campus. Look at faculty, bring together faculty lead, industry mentors, uh, and bridge academy stakeholders, and design a pilot and deploy the pilot and evaluate the pilot for in terms of sustainability, scalability, etc. And then you can always fine tune and scale. I believe this is a model that should be the future way to design and deploy curriculum. And what do I want to finally summarize? What should be the role of academia? Focus on deployment of and fine tune the curriculum with a collaborative framework involving the industry and or the bridge academy. Uh, Focus more on, I think one thing that I always tell when I go to university visits, I say that focus on the process of learning, and completing the syllabus is not as important, because if you equip the students with the process of learning, they can learn the rest of the syllabus that we cannot complete. So this is an interesting one that it's a difficult thing for academia to embrace, but completing a compressed syllabus is not as important as imparting an ideal process of learning. I think innovation and entrepreneurship is very important. So embrace a hybrid model like this in some version of this. And I think faculty development programs are important. Involve the industry in resetting or reorienting the faculty on the industry requirements or industry problems. And do invite industry experts. I think this is a call to academia. And I think many of the experts want to go back to their roots, give back to their roots. So at least I see that in my environment, that it's kind of a service back to society and mindset, right? And for industry, I think industry is important to co-invest in education, provide the resources, data, platform, experts, time, which is the most important. And I think need to engage in with learning partners, motivate their employees to embrace it as a social responsibility. And I think this is how you can foster kind of a self-reliance that we as Indian nationals proudly speak about, right? I think defining and updating competencies is very important to make it transparent to the rest of the world, academia included, so that they can always calibrate, fine tune their curriculum, right? And then very interestingly, new credentials. I think we need to have students look at new credentials. Don't look at CGPA as an important, just the only important way to evaluate, but project portfolio, competency based on achievements like a certification, a course should all be something that we need to recognize the students. So in summary, I don't think skill gap is an insurmountable crisis. It is there, but it is not an insurmountable crisis. We need a collaborative innovation. I believe it provides us an opportunity to innovate, right? How do you innovate? By embracing a modified, fine-tuned curriculum, but deploy it in a pedagogical model which is more innovative and hybrid, where it prepares the graduates not just to be job ready, but career and future ready. Have agile learning systems with disruptive technology, embracing the disruptive technologies, build sustainable partnerships that benefit learners, educators, and employers. So you need a collaborative ecosystem and sustainable partnerships. And then, of course, that should lead us to transformation of engineering education for the digital age. So with that, I want to conclude and say that one more time, that collaboration, innovation, and shared commitment to excellence. The key word here is shared commitment and collaboration. So with that, I'd like to thank um, Hexagon for giving me this opportunity, and happy to take any questions.
Yeah, thank you so much, Dr. Murali, for that insight. I know it's been a lot of information. I hope people have been taking notes for this, because you've given a clear call to actions for industry, for academics, and yeah, landscaping, something new that even I have learned. So it's a new term that sure we're going to catch up. And rightly said, I think this skill gap that we see, it's something that we can actually solve. We just need to take care of the multiple parameters that impact curriculum, faculty development, industry involvement. We do have few people who want to ask few questions. Just from my side, we've spoken a lot about the skills in terms of the technical part that is required. I'm wearing a student cap. I'm just doing my third year, final year, undergraduate right now. I'm looking towards industry. I have a lot of things that I'm learning, I'm trying to develop, but always that transition from the university to the industry, the first year, the first couple of years is going to be a lot of difficulties, change of place, change of food, maybe change of a lot of other environment. Is there any specific skills that you would suggest that a student should be ready as they are moving this transition, and so that can be made a bit easier for them from the university to the academy for the industry side?
Yes, good question actually. The biggest adjustment is what we call workplace or professionalism proficiencies. So I think if you are practicing professionalism as a student, and this you do in internships or you do it while actually simulating the professional environment, and which is what I spoke about, the hybrid pedagogical style, right? So if you think about what we do in the industry, we are actually daily attacking some problem, right? Product design problem, simulation, a simulation problem, or we are solving a quality issue. So all of these are really problem solving, and we are all solving it as a team. So in a way, what I'm saying is here is that one way you can seamlessly transition from university to the professional world is actually practice this being as if you're in mock the professional world. And mocking the professional world means what? You're able to do system thinking, you're able to solve problems which may be cross functional, you're able to do plan and manage your projects, you're able to collaborate with multiple stakeholders, even cross culturally and across geographical divides, right? I think getting used to this professional environment is an important, and practicing that in the university is very much possible with the kind of uh, role kind of cohort mode of problem solving projects that you can execute as part of curriculum. I think you should be find it easier. Of course, change of place, change of scenario, these things you have to get used to, but I think many times what I see is internships take you far away from home. Maybe it takes you in a professional world, get you exposed to mentors. And I think this way you can actually expand the internship to be more integrated in between academia and industry. Okay.
Yeah, that's perfect, Murali sir. Yeah, I think that's exactly what need to. We talk about virtual simulation engineering part. I think they need to create a virtual environment during their undergraduate so that they can replicate what happens within the industry side. A very quick question, Charlotte. You want to ask a question to Dr. Murali
Yes.
Subramaniam?
Please go ahead.
Hello, thank you. And
Thank you.
it's good morning for me. And just saying that I'm wide awake now. I'm sitting straight up. A great presentation. I'm just wondering if you see if this landscaping is dependent on the industry support. I mean, do you see difficulties to getting industry to commit to make this work? Because I know that I'm willing to reach out as a professional, but I can't spend too much time because I have to also deliver. So what do you see?
Yeah, I think industry involvement is paramount. Why? Because when I talk about problem-based learning, the problems, where do they come from? The source of the problems is curated by industry along with academia. So industry needs to invest time in actually digging their problems from the past, maybe, or even some present problems, curate the problem for student. Maybe you get good solutions. In fact, we worked with a university. We donated an electric vehicle to them, so they have dismantled it and working on it. And we gave them a handful of problems that we encountered: battery thermal management, or electric vehicle noise and vibration. And you will be surprised that the students are smart and they are capable of thinking outside the box. So actually, it's worth industry investing, providing the problems, providing data, but importantly, providing time, like Charlotte, time of yours, for example, or your colleagues, some amount of time. And it's not necessary that you need to travel and go to these universities. It can be done remote collaboration these days. So all you need to do is dedicate some time, maybe half an hour or 1 hour a day, maybe, or it could be a couple of hours a week, to mentor the students, to assist the faculty, for example, in curating some of these problems, evaluating the projects, contributing by sharing your experience and knowledge. So I think it is a win-win proposition, but at the end of the day, you're going to recruit from the academia, and you're going to invest in time into them anyways. It's going to be your time anyways, or you're going to pay a lot of money to some external training partner to train these people, but still they are not going to be productive for a period of time. So you are going to gain in actually being upfront in the education phase of the student, so that they are more ready, and you need to invest less of your time, resources, money to get them bridge that gap when they get out of college as graduates or postgraduates and get into industry mode of productivity. So I think I think industry involvement is paramount. And I think in a way, industry is busy with their work, academia is busy with their curriculum, and that's where I think there is opportunity for bridge academies, academies that are integrated with the industry as well as academia. So I think there are unique organizations like that, and I believe Hexagon might be one of them. So I hope, Charlotte, that makes sense what I said.
Great, thank you.
Sure. Yes, Dr. Murali, I think Hexagon is definitely trying to put a step there, bridging the gap, because we clearly see the demand that is coming from the industries, from our customers especially.
Yeah.
And when we go to the universities, we see the requirement. We just try to take a one more question. Irfan, we've given you the mic option. If you can ask a quick question, just we're running out of time. But can you speak? Yeah, Irfan, please go ahead.
Yeah, can you hear me? Hi.
I can hear you.
Irfan.
Yes.
Yeah. So, Dr. Murali, I think it was very fruitful discussion, and very key takeaways are like the landscaping and also giving back to the society. I think these are the two key essence. So I would like to take your insight and also a practical way on one specific problem. See, if industries are able to utilize, more than giving an opportunity, utilize the academic excellence and the knowledge base and also the time of the research scholars, that could be of a good win-win situation. For example, any kind of a digital manufacturing, additive 3D printing, rapid prototyping, for example, I'm saying. So those kind of areas would be of very fruitful for any researchers who are in the academia. They'll be able to do iterations, spend enough time, quality time, do enough iterations on the simulation side, then go for a printing. So those kind of a time consuming and the quality work, if it is shared with academia by the industry, I think both sides it will be benefited. And there are a lot of ways of giving data in an encrypted mode so that that confidentiality, those things are maintained. So being a leader in the industry, I would like to take your vision or your say on this. How far it is practically possible? How far it is a viable collaboration between academia and the industry by utilizing these application sites?
This is a great question, and I can give you an example as Stellantis in our region. What I did was I immediately formed an umbrella MOU with a university like IIT Madras in Chennai and SRM in Chennai, and we have other universities. So one of the collaboration framework was research projects actually, and I believe sincerely that academia has the aptitude and the ability to do the right kind of research to solve problems, industry problems, especially futuristic vehicle problems. And we did one exercise with IIT Madras where we actually, their research scholars in a department along with faculty actually did the project. Only one project mentor was from Stellantis. We provided the data. We had an MOU confidentiality agreement. So this is not a big deal. So it's not a problem. All over the world, Stellantis, for example, in Italy, we work with Polytechnic Torino. In North America, we work with Ohio State University and Oakland University and similarly in India and other regions in China, we work with the Shanghai Jiatong University. So we have MOUs with different universities, and precisely what you're saying is actually not a sort of a feeling of we're not doing any charity here. We are actually getting our problems solved by the academia. So like I said in the first slide that I showed, the academia is instrumental in giving breakthrough problems for us. So we are doing this actually as what you say, and we are reaping the benefits of this because our product engineers have a certain mindset which we need the student population with their open mind and kind of a free thinking, out of the box thinkings, with also gaining the vital experience. So we actually hire these students once we are done with this project. So this is very much happening with Stellantis. I think in a way, it's a model that definitely works. You have to definitely define the scope of your work very clearly. You have to work with the academia that needs the time. and some of them do have all the resources, but you need to provide the necessary orientation for them.
2 minutes, give me. I'll call you back. 2 minutes, please.
Yeah. So I think that's pretty much it. I hope I answered your question, but it's actually happening the way you want to, the way you envision it. It's already happening, and I can say that I was leading a project like that. It was really beneficial for me that we were able to get more than what we wanted. But only thing is that academia needs a time if you want to do a project like that. So there might be opportunities to do a lot more broader internships, bring the students on board, have collaborative teams between us, industry and academia, research scholars, for example. And some of these inquiry-based learning that I spoke about as one of the wings of the hybrid pedagogy is that we need to do research. And who better than actually students from academia? They are actually doing this, whereas the industry engineers are not as equipped with the process to do research. So I think there is a positive synergy that's possible with this. Yep. Okay.
Thank you. Thank you.
Thanks, everyone, for that question. And thank you, Murali, for answering it so detailed and clearly. Once again, we can't be thankful enough for your time, for the information that you have given. There are some more questions, but I think with respect to time, we're just running out, right? So we'll send you some questions. Maybe you can just give us a small message and we'll transfer those to later. So thank you once again. You're always free to stick around to see some of the other speakers. And once again, we'll send a lot of details out to the students as well as to you regarding the entire session. So thank you once again, Murali. Bye.
Thank you for inviting me. Thank you all.